Hello and welcome to what you've all been waiting for, Maths for Grade 12s on Learn Extra Live. How are you, Heather?
Awesome. How are you?
I'm great, thank you.
Good.
We're doing paper 1 and 2 revision today.
We are. We're going to be doing some calculus, some analytical geometry, and some trig if we've got the
Wow,
time.
that is jam-packed.
Okay.
It's going to be such an awesome show. Guys, ask everyone to join us today because I know everyone needs revision on paper 1 and paper 2. Hey.
Well, that's what they need to concentrate on to
That's
get
it.
their maths standard up for the university.
That's
Paper
it.
1 and 2, paper 3 is an optional.
Yes, that's it. Thank you,
Okay,
Heather. You can go over
great.
to the board. So, guys, as you know, it's Maths Mondays. Therefore, we have some awesome prizes to give away. We have our Casio calculator as well as our Casio labeler. Make sure that today you are the most fantastical, most awesome member of the show so that you guys can stand a chance to win these awesome prizes. And thank you again to Liberty for bringing us this show. And guys, of course, you know, Learn Extra. You guys know facebook.com/Learn Extra, and our Twitter handle is @LearnExtra. Make sure that you are so fully involved, guys, because it is your exams very soon. Your exams are kicking in. They are basically knocking on the door and breaking it down, so that make sure that you guys actually know everything there is to know, because there's no excuse to fail, guys. There's absolutely no excuse because we are here to help you. Heather, we are so ready for you.
Good. Okay, so guys, what we're going to have a look at is what at the beginning of the section I get told just to do revision for paper 1 and paper 2. So what I like to make sure of is those easy marks, those core skills. So from paper 1, I've chosen a calculus question. And of course, what I'm going to be doing is pointing out to you, these are the marks you've got to get. I'm not really interested in getting you from 85 to 100. I want to make sure that you're going to get that 40% of the core stuff so that you're really confident to be able to do the easy stuff when you walk in. Then I'm going to do a bit of analytical after the break, and then hopefully some trig as well. Okay, so let's just recognize the kind of question. Of course, in calculus, one of the most important things that you need to be able to do is to work with cubic functions. They can either get you to draw it, or they can get you to interpret it. And of course, the trend is more to interpret rather than to draw. Okay, so the question says, the sketch represents the graph of f of x is ax cubed plus 5x squared plus 4x plus b. And then they tell you D and E are the stationary points. So I'm just going to make sure that I'm aware that those are going to be what we call turning points or stationary points, okay? And then they give you quite specifically that F has got the value of 0, -3. Now, remember that all this stuff that they give you is important, okay? So there's my eyeballs. You must look at it. You must not regard it as bump, okay, or superfluous. It's there to help you. All right, the first question actually says to us, prove that the value of A is -2 and B is -3. Now, it's this A that they're talking about and this B that they are talking about, okay? Now, remember that when they say prove that, do not work backwards. Do not assume that A is -2 and B is -3 and work backwards from that. Assume that they have just said to you, find A and B, and then you've got the luxury of checking that your answers are correct at the end. Okay, now, let's have a look at the A and the B. Look at the B value, all right? Can you see that that is actually the Y cut? Because remember, if X was 0, your Y value would equal B. Now, that's where this comes in. Can you see that the Y cut is at -3? And so quite kind of automatically, we can see that the B value is -3. But we have to show them that. Because if we just write down B is -3, they think that we're cheating, that we've kind of just leached off this thing. So I'm going to say F is the point 0, -3. This is my Y cut, which obviously means that my Y is equal to A times 0 cubed plus, right? What was my original equation? Let's just pick it up, 5x squared plus 4x. So it's 5x squared plus 4x plus b. And so that means that when I substitute my y of minus 3, I get my b value to be minus 3. So now I'm feeling great because you can see that I've actually said that the b is minus 3 as they told me. Now I have to prove that the a is negative 2. Right, how am I going to do this? Now, guys, one of the most kind of powerful things when you're doing graph interpretation is if you are ever given a point, plug it into the graph. Okay, it will always have some kind of an effect if you plug it into the graph. So let's have a look at what happens if I plug that in. I'm going to get 0 is equal to a times negative 1 cubed plus 5 times negative 1 squared plus 4 times negative 1, and my b value I have just proved is negative 3. So all I'm doing is I'm substituting the point negative 1 naught in because it lies on the graph. And you can see what's going to happen here. I'm going to get naught is equal to a negative a, all right, plus a 5 minus a 4 minus a 3, and you can see there that you now are going to have a's value is negative 2. So what can you do? You can pat yourself on the back and you can say, cool, I've done what they told me to do. Now let's just say that you couldn't do this question, all right? You couldn't do it for whatever reason. At least now you've got the values of a and b in going forward, okay? So it says now for the second question, determine the coordinates of D and E. Now I'm hoping that as we go through this question, you are going to be able to say, they always ask me that. Okay, they do. They always ask you to find the coordinates of the turning points. So now remember, your cubic equation is going to be negative 2x cubed plus 5x squared plus 4x minus 3. So I have used the minus 2 and the minus 3. They are now defined. They're not unknown as they were previously. Okay, so how do I find D and E? Right, remember that for your turning points, we know that at the turning points, our gradient of our tangents, all right, if I were to draw my tangents in there, the gradients of those horizontal lines is 0, which means quite simply, guys, that you are going to take the derivative, and of course your rules are bring that down, multiply by the coefficient, so we are going to get negative 6x squared, then bring that down and multiply by the 5, we're going to get plus 10x, then we are going to get plus 4, and we know for sure that that has to be set equal to 0 for the maximum or the minimum. Both of them. Makes no difference which one you're looking for. Both of them have a gradient of 0 at that point. Now, I don't know about you, but I strictly try and work with coefficients that are positive, which means that I'm going to divide through here by negative 2, and so I'm going to get positive 3x squared, negative 5x, subtract 2 coming to 0. And of course, if you are good at trinomial factorizing, you will be able to see that this one is quite nice because the 3 is prime, so we just take 3x and x, and then it's really just a question of where do we put the 2 factors, and so I'm going to get 2 times 1, and if I make that a negative 2 and I make that a positive 1, and I quickly check back, I've got the right factorizing. So my x value is negative 1/3, or the other x value is 2. Right. Now, guys, whenever you do one of these questions, it's a good thing just to check back and see if the answers that you get are actually reasonable. So I've got x is negative 1/3, which would have to be the x coordinate at E, which is reasonable because this is minus 1, so it has to be bigger than negative 1, but still negative. And then the D coordinate looks reasonable, even although it's not to scale, it's a 2. All right, then of course, guys, you now have to go along and use your calculator. And I'm not wasting time with calculator work. I just previously worked out the answer. I'm going to take the negative 1/3 and sub it back into the equation. And I actually get an answer of negative 3,7 for the y value. And if I use the 2 for the x value, I'm going to get a value of 9. And so I've done what I've set out to do. I've got my D coordinate is going to have 2 and 9, and my E is going to be negative 1/3, all right, and negative 3,7. And again, I'm asking you, I'm begging you to check that your answers look reasonable. Not to scale, but reasonable. Okay, the next question, all right, determine the stationary points of G if G of x is the f of x plus 1. Now, just look at the graph. There's only an f. They are wanting the coordinates of the stationary points of a new function g, but can you see that g is a transformation of f? So g is a transformed or transformation of f. All right, now let's have a look at what happens of f. If we have plain f, but now we are taking the f of x plus 1. Right, how does this transform? Now, guys, I know that some of you do battle, but if we have something like x squared as a graph, and then we have x plus 1 squared, how are these two related? Well, this graph is just this one moved 1 unit left. All right? If I had something like y is x minus 3 squared, then this graph would be that same graph, but moved 3 units right. All right, so in other words, what you need to do is understand that the transformation is what happens if I put that equal to 0. X would be negative 1, so it moves it negative 1. Here, x minus 3 put equal to 0. I would have x minus 3 equals 0, so x is 3, so it would move the axis of symmetry 3 to the right. So all that I have to do for this, not much at all, is I actually have to look at the stationary points for f, right, which were here, and I need to move them 1 to the left. So in other words, the stationary points would be negative 1 and 1/3, all right, before they were negative 1/3, and 2. So this is now moved 1 to the left. That must move 1 to the left. 2 minus 1 is 1. The y value would stay the same. All right, that just did a funny squiggle. The y value would stay the same, and the y value would stay the same for the other one, which is negative 3,7. Okay, that's a thinking question. That's not really, really basic. It is thinking, but it's quite a common question. All right, moving on. Same graph, but now they want us to calculate the length from A to C. All right, now I can hear all of you at home saying that in order for us to know the distance from A to C, we need to find the coordinates of C. Now remember, C is another x cut. All right? So what we need to do is we technically need to find A, B, and C to work out the distance from A to C. Okay? So guys, we've got our equation. It's minus 2x squared, and then it's minus 2x cubed plus 5x squared plus 4x minus 3. And we want to find the x cuts, which means we're going to put it equal to 0 for the x cuts, okay? Now, as I said before, I prefer to always work with the positive, so I'm quickly going to change this to 2x cubed minus 5x squared minus 4x plus 3 is 0. Now, looking at the picture, you know that the 1x cut is at -1. Therefore, you know that one of the brackets is x plus 1. In order for it to cut at -1, one of the factors would have to be x plus 1 for the root to be -1. Now we need to create this factor or linear factor which multiplied by this one gets me back to the original. And I know that teachers go into different methods. Mine is purely by inspection. And so I say x times what would get me to 2x cubed. And so that's an easy answer of 2x squared. Then at the back, plus 1 times what would get me to plus 3. Then this is going to be a plus 3. Then what I do is I multiply these two numbers together. All right? Can you see that by multiplying those together, I get 2x squared? I look up at the top and I see that I need negative 5x squareds. So the only way that I can get from 2x squared to negative 5x squared is to actually subtract 7x squared. And you will notice that when I multiply this by this, all right, when I multiply this guy by this guy, it gives me my negative 7x squared. So what I've now got is x plus 1, and then I need to trinomial factorize this quadratic, which factorizes into a 2x with an x, and then I'm going to get a 3 with a 1, and using my signs, that's going to give me a negative as well as a negative. And so I'm now going to get my x answers to be negative 1, which I knew was going to happen, and that is at A. Then I'm going to get x to be a half, all right, and that must be at B. And then I'm going to get x to be 3, and that must be at C. So to answer their question, what is the length of AC? Then clearly, using my knowledge from A to C is going to be 4 units. Right, marathon question, but we're nearly done. Find the coordinate of the point of inflection. Now, guys, remember that if you have any cubic, all right, the point of inflection is going to be that place where it kinks differently. So it changes from being concave up to concave down. So it basically is going to be halfway between the two x coords of the turning points. Okay, now that's the one way that you can work it out. The second way that you can work it out is to actually take your second derivative and put it equal to naught. Okay, so remember that our first derivative way up here, all right, was negative 6x squared plus 10x plus 4. So our first derivative was negative 6x squared plus 10x plus 4. So our second derivative, just taking the derivative again, all right, is going to be negative 12x add 10. And what did I say you need to do? You need to put that equal to naught. And therefore, we've got negative 12x is equal to negative 10. So x lands up to be 5/6. Okay. Now remember, they just said find the x coordinate of the point of inflection. They didn't say find the coordinates. So we're done. I've got one more section.
Can
2
we
minutes.
go for a quick break, and then when we come back, we'll do that
Tie it
one
up.
right away?
Cool, no
Awesome,
problem.
guys. Let's just go for a break. This is for you guys to refresh yourselves, to get something to drink on this warm day. We'll see you right after this very short break.